Today we're going to talk about the most boring piece of equipment in the electronics lab, a DC power supply. It makes no cool waveforms like oscilloscope, can measure your internal resistance after you drank 2 pints of beer like a DMM, and unlike generator can create any cool sounds. But in a way, this is the most essential piece of equipment in your lab because without it, you can't power up anything, can't check anything. So it must be on the bench or you can't do any work with the other cool pieces of equipment. So today we're gonna see which power supply is actually better for the job and whether it makes sense to buy a super expensive one, buy a new one that's cheap because it's made overseas, or buy a used one that was once made in this great country of ours, but sadly no more. But it's still available in the used market. So we're gonna start with the BNK 1745, and we're gonna try to check it out, see what happens. Wait a second. What happens is that I turn the voltage knob, and this thing clicks. It's like there is a metronome there. Every time I increase the voltage, this thing trips. That's very strange. Yes, that's somewhat strange. So let's try it with the load and see what happens if we connect a 40 ohm resistor. Uh-oh. It's even worse. It's like keeps now firing like relays in the old telephone exchange. Okay. Maybe it's broken. So let's turn it off and move on to a next brand, Topward. Okay, that's a good Taiwanese brand. And let's change the voltage on this one. Uh-oh. It also has a clicking sound. What's going on? Why is this power supply clicking also? Okay, let's put the load and see what happens. Yeah, it clicks when we hook up a load too. Okay, maybe both are broken. Okay, sorry. Let's move on to the next one. This is Sorensen, but it only says Sorensen on the front. In reality, this is made in Taiwan by Instack or some other similar brand. So let's first we try the voltage. Again, this thing clicks every time we raise or lower the voltage. Let's try the load. Same thing. We attach the load, this thing starts clicking. What's going on here? Why are all these three power supplies are clicking? We don't know. Okay, we have one more to test. That's an old HP Hewlett Packard US made power supply. 40 volts power supply. Okay, no, first of all, strange, no fan. I wonder how they were able to design something without the fan. And let's switch to the voltage scale, and we're gonna raise the voltage. I'll be quiet when I raise the voltage all the way to 40 volts. No clicking. Okay, let me connect the load and see what happens next. Okay, I connect the load. Still no clicking. I go all the way to 40 and there is no clicking. Or maybe it's not working. Maybe it's not actually meters working and nothing's happening. Okay. No, it does give registers current. In fact, you can see sparks even flying out of the output. So it's definitely working, but yet there is no clicking. Kind of hard to do it with one hand. Okay, 40 volts with the load, no clicking, folks. Amazing. How did they do it? Well, remember, we also got to a moon at one time, like 50 years ago. So what's going on here? Why are these power supplies clicking? Obviously, there is a relay in there. So let's take a look and see what's going on. Okay, so we opened one of these power supplies up. It's ProTech. And what do we find inside? We find inside Chung-Won relays, right there, 2 of them. Okay, plain electromechanical relays. And these Chung-Wong relays are there in order to save money on the overall cost of manufacturing of the power supply. And here's the schematic that shows you how it's done. If you look at the main power transformer, you will see that it's multi-tapped on the output. So when you want to get a higher voltage, the relay switches to a winding that's rated for a higher voltage. Okay, and that's why we hear this clicking. And you lower the voltage, it clicks again because it has to switch to another winding. And obviously, these relays, if they carry a current at the maximum rated current level for the power supply, they will be arcing, or the contacts will be wearing out very quickly. To begin with, relays are way less reliable than any electronic component, but when you operate them in some region where they're close to their limit, you can expect nothing but trouble. Now that we covered the most important drawback of inexpensive offshore power supplies, let's look at some other drawbacks, less serious perhaps, but nevertheless they will contribute to early failure of offshore brands. So here's the very old HP power supply, okay, and not so old newish top-word power supply. And we're going to look at the front panel. Well, HP front panel, of course, is broken, but we can see here the potentiometer still has a good shaft and it works just fine because it's a thick metal shaft right there. And potentiometer itself is not your regular potentiometer like a volume control on a stereo. This is a wire wound potentiometer, which is like top quality. It's pretty much it can be worn out basically. Okay, this will last forever. So you can see this power supply was dropped, the panel broke because it's plastic, but the shaft is still okay. And the most amazing thing, we still have knobs. Okay, knobs didn't fall off. The knobs didn't fall off because they use set screw to tighten the knob. And get this, they actually have 2 set screws per knob. This thing is designed to be thrown out of the train, okay, and not to get damaged. Now let's look at topward. Okay, topward, here's the potentiometer shaft. It's plastic, it's not metal. And why there are no knobs? And there are no knobs because they fell off long time ago, because on topward power supplies these knobs just come off. Go on eBay and see how many of these power supplies missing knobs, because they just come off. They have no set screws. They're just like slide on, slide off. And what kind of potentiometers does the topward use on their power supplies? Okay, let's take a look. Oh my God, that's a potentiometer from cheap stereo. Okay, look at that. Look at that shaft. Look, you can break it with one finger. Look, I already bent it right there. This is what you get from offshore brand. Okay, complete junk. Okay, enough of this superficial comedy routine. You already know that I'm biased and I'm in favor of an old HP power supply for valid reasons. But if you do not believe me, just compare the specs for, let's say, B&K and the old HP power supply we used in this video. And you can see HP power supply spec is way longer than B&K because they spec the things that B&K doesn't even mention, like long-term stability or temperature drift. Also, HP guarantees power supply to be unconditionally protected against shorted output at any voltage level, at any current level, and so on and so forth. So it's not me, it's technical data, and technical data does not lie. That's why all serious people who do electronics prefer older HP power supply for their reliability, predictability, and long-term stability. Okay, and additional feature of this power supply that the others don't have is remote control via analog potentiometers and remote current sensing. Also, if it does fail, that would be a very unlikely event. If this power supply does fail, it's very easy to service. because the circuit board is separate from all other big components. You don't see it's on the bottom, but it's easily accessible. Manuals are readily available with all parts lists, with all the schematics, and so you can fix the power supply and be in business again in no time at all.